Can you all see my screen?
Yes, sir. Yes, sir.
Good.
Yes, sir. Yes, sir.
Okay. Thank you. So, as Professor Swai told me, I am Professor and Head of Department of Biotechnology and Medical Engineering at NIT Rourkela. Okay. So, today I will be talking about the effects of sorbitol monostearate and stearyl alcohol on physicochemical parameters of sunflower wax based oleogels. Okay. So, as I a few moments back told you that it has been recently published in the journal Gels. Okay. So it was a collaborative work, and we had Professor Duman Kim from Seoul National University, and which is in South Korea, and we also had Derek Russo from Ryerson University, Canada, and their inputs in this work it was really helpful, and we came out with some good results. Okay, so starting with my presentations. So the term oleogels, it may be a new word for many of you. Okay, many of us who are from the pharmaceutical background, we have mostly heard of the term hydrogels. Okay, now what are hydrogels? Hydrogels, they are basically gels of aqueous systems. Okay, so they have a 3D matrix which holds aqueous systems. Okay, in oleogels, if you compare this the term oleogel and the hydrogel, you will find there is a term called oleo, and this oleo word, it comes from the word oil. So the term oleogels means gels of oil. Okay, so when we talk about these oleogels, we are basically talking about the gel based systems which consists oil as its liquid component. Okay, now do we have oleogels in our home? The answer is yes. Okay, the reason being, if you take the examples of butter, also if you can take the example of ghee, what are they? They are fat structures which is obtained from the animal sources, and they may have certain amount of liquid systems within itself. Okay, so these solid fat structures, it forms a network and it immobilizes a certain amount of oils and even water molecules into its this fat structure. Okay, in the butter and the ghee. So what is happening over here? The structure what we get in butter and the ghee, they are also oleogels in nature. However, what happens is that the amount of the saturated fats in the butter and the ghee, it would be so high that it gives a solid like structure. Okay, now what we can do to make an oleogel system from the butter or the ghee? If you take the butter and the ghee and add some say vegetable oil, say sunflower oil, and you add those in slightly lower concentrations, you will find as you are trying to increase the sunflower oil content, the texture of the butter or the ghee, it is changing towards the semi-solid nature. Okay, however, the what happens is that this still remains the gel. Okay, so just from a solid like consistency of the butter and the ghee, we are coming to semi-solid structures, okay, which is having a texture similar to say ointments, okay. So what we are doing, we are developing a system which is basically made up of oils, okay, which is having a higher amount of oil into it, okay, but it is semi-solid in nature. Now these kind of systems, they are regarded as oleogels, okay. So when we talk about the ointments, ointments can also be classified as an oleogel system, okay, because if you see, they are also semi-solid in nature, also they are having the majority of the liquid fraction, it is the oil. Now you would ask, then what is the difference between the normal oleogels and ointments? So we should have called the ointments as the oleogels. True, we quite interchangeably we can use the word oleogels and the ointments, right? But the thing is that in oleogels, what happens is that we mainly consider that it is having only two categories of items. The first item is the oleogelator, which will induce gelation, and there would be a hydrophobic liquid which will be entrapped by the oleogelator, okay. Now in the butter ghee, they are also a kind of oleogel, but technically they also have some moisture into it. It may have certain other components also, but these butters and ghees, they are what you call much more sophisticated type of these oleogels, okay. Another problem with the ointments is that it may contain a large number of components, and they are prone to what you call this destabilization, okay. If you keep the ointments for a prolonged time at a room temperature, they may undergo destabilization, okay. On the other hand, when we talk about the oleogels, they are only containing two types of components, oleogelator and the hydrophobic liquid, and this hydrophobic liquid is mainly the vegetable oils, and these vegetable oils, what we use, they are obtained from the nature, and inherently they will be having a large amount of antioxidants, okay. So due to the presence of these antioxidants in the vegetable oils, what happens? The stability of these oleogels are very high. So the stability over here is very high, okay. Now the process of conversion of the vegetable oil into a semi-solid system, it is regarded as oleogelation, okay. It is regarded as oleogelation. Now when we talk about the oleogelators, also there are various types of oleogelators that are available, okay. The first is polymeric oleogelator, okay. The example is ethyl cellulose. Then there are wax based oleogelators. One of the common example is beeswax. There are other waxes like candela wax, you can have sunflower wax, okay. So these waxes, they can also be used as the oleogelator. Then there are certain emulsifiers. There are certain emulsifiers. Say for example, our group have worked on 280 span 80 mixture to develop oleogels. Okay. Similarly, there is a very commonly used emulsifier, food emulsifier, which is called lecithin, which can also be used for developing the oleogel based systems. Okay. So among all of these, if you look into these wax based systems, they are very commonly used for the preparation of the oleogels. Why that is so? The reason being, when we talk about the waxes, they are present in the nature, and since they are present in the nature, they are very cheap. So you can develop a semi-solid system in a very cheap price. Okay, and also the systems developed over here, it would be very very stable in nature, because of the reasons which I told you few moments back. Okay. So in this study, what we have done is that we have tried to develop an oleogel system which was made up of sunflower oil and sunflower wax. So both this sunflower oil and the sunflower wax, they are derived from the sunflower plants, right? Sunflower oil, most of us, we consume it in our day-to-day routine life, and many of our mothers and wives, they will be having this sunflower oil in the kitchen. However, we have not heard about sunflower wax much, right? So what are these? These are basically the waxes which are obtained from the seeds of the sunflower. Okay. The advantage over here is that these sunflower wax, it is basically a waste material from the sunflower oil industry. So basically we discard them while processing the sunflower oil. Now this sunflower wax, it has got advantages or the applications in cosmetics, in pharmaceutical industries, in food industries. Okay. So many people, they have found out some of the applications in these areas, and they are quite commonly used. Okay. So we thought, okay, let's try to use this sunflower wax to develop an oleogel. Okay. So what we did is that to the sunflower wax, we added sunflower oil, we added sunflower wax in different concentrations, and then we heated it, because sunflower wax, it is solid in solid at room temperature. Okay. And when we started increasing the solid content of the sunflower wax, we found that at 5% composition of the sunflower wax, the sunflower wax was able to induce gelation of the sunflower oil, so that we have sunflower oil, sunflower wax, oleogel. Now you compare the butter and the ghee and this oleogel. In butter and ghee, if you see, they are having a solid like structure or even the semi-solid like structure. However, to induce that semi-solid structure, we are having saturated fats which are present in this system at a concentration as high as 80%. Okay. What I mean to say, that butter and ghee, they are having saturated fats at concentrations as high as 80%. Now suppose you want to consume the butter and the ghee at regular intervals every day, the high content of the saturated fat would lead to cardiac diseases. Okay, so in that way the food researchers, they are working towards these oleogel based systems where we can reduce these saturated fats from 80% to as low as 5%, or in some cases even 10 to 15%. So you can see the marked reduction in the saturated fat content in these semi-solid systems. So if you are using these semi-solid based systems for your food applications, which can also be used to deliver nutraceuticals to the human body at what you call in regular intervals. So what we are doing, we are creating a healthy alternative to the butter and the ghee systems, which we are using it in our daily lives. Okay, so as you see, what are the advantages of the sunflower oil? The advantages are easy digestibility. It is having antioxidant property, which would give the increased stability during the shelf life, and it also helps in the body fat reduction. What are the advantages of the sunflower wax? It is having lower critical gelation concentration. That means it can gellify the vegetable oils at very low concentrations, and in our case we found out that for the sunflower oil it was 5%. Okay, then as I told you, sunflower oil it is very commonly used in the households, so we can get the sunflower wax from the sunflower oil industry itself, which is regarded as the waste. Okay, so we would be having an easy availability of the sunflower wax, and lastly it is having high structuring ability. That means it is able to form a 3D network structure which can hold a large amount of the oil. Okay, now after developing this oleogel, we were thinking, can we alter the properties of the oleogel by adding some emulsifiers? If you remember, I told you few moments back that emulsifiers, they themselves are being used in many cases to develop oleogels. Okay, so our main aim was that we will make sunflower oil and sunflower wax based oleogel, and then we will add emulsifier as an additive. Okay, whereas when I told you that emulsifiers can be used for the developing oleogels, over there the emulsifiers, they were being used as the oleogelators, so they were not the additives. Herein, in this case, what we tried to do is that we tried to gel sunflower oil with sunflower wax using emulsifiers as the additives. Okay, so what is the reason? When we talk about any waxes, they consist of these fatty esters and also the fatty acids. Okay, so they are having a polar group and a apolar group. Now when you are trying to form the gel, what happens is that these fatty acid groups, they form a network like structure, a strong structure which is forming networks of the fat crystals, and within those crystals you will be finding that the oils are being entrapped. Say for example, if you look into this polarized light microscopy, this one fats three-dimensional network, so these bright crystals, they are nothing but the fat crystals. Okay, and the dark phases, what we are seeing over here, they are basically the oil phases entrapped over there. Are you getting my point? So we can see the fat crystals, they are crystallizing into some solid form, and then they are forming the network, and due to that network formation we are having some void spaces, and within that void spaces the oils are getting entrapped within the gel based systems. Now when we talk about these emulsifiers, and especially when they have different HLB values, say for example sorbitan monostearate, that is the span 60, it is having an HLB value of 4.7, and stearyl alcohol it is having an HLB of 15. So I believe that all of you know what is the role of HLB and due to what reason this HLB value changes. Okay. So as we know, these HLB value systems, they play a significant role in selecting an emulsifier for stabilizing either oil in water or water in oil systems. Okay. Further, when we looked into the literature, we found there is a great scientist, Nissim Garti. He is from Canada. He has worked on modulating the properties of the fats using the emulsifiers. Okay, using the emulsifiers. So what he does is that he modulates the properties of the fats by adding emulsifiers in lower content. We thought, okay, let's try, because in our case we are having sunflower wax which is at a concentration of as low as 5%. Let us add some additives over here and see whether these emulsifier additives having HLB values drastically different HLB values, they can tailor the properties of the what you call the oleogels. Okay, it is important to note over here is that both the emulsifiers, they were solid in nature, and we intentionally did that. Why? Because if you see, you will get at low HLBs or even the high HLBs, we can also get emulsifiers which are liquid in nature at room temperature. So we want to eliminate the effect of this physical state of the emulsifiers on the properties of the oleogels. Rather, we wanted to concentrate on the properties of the oleogels based on their HLB values. Okay. Now, as I told you, how we prepare these oleogels, we have the vegetable oil. To that we add this wax at a temperature which is higher than the melting point of the wax. Okay, we solubilize it, and then similarly for the control sample we do not add the emulsifier. However, for the test sample we add the emulsifier at different concentrations, which I will be discussing later on. Okay, then we cool it, and after the cooling, what happens? We get the oleogels, and this is the microstructure of a typical wax based oleogel. Okay, I hope I have been able to clear any of your doubts why we are doing this. Okay, now just a brief idea about the HLB scale. So this is the HLB scale, which varies from 0 to 80. So values of 4.7 for the span 60 sorbitan monostearate, it was 4.7. So it is a hydrophobic or oil soluble emulsifier, whereas our stearyl alcohol, it was having an HLB value of 15, right? Stearic alcohol, HLB value of 15. So it is a water soluble emulsifier. Okay, so now we want to see what is happening over here. Now the oleogel preparation, I told you, we mixed sunflower wax. To this we added this sunflower oil was there, then we added this sunflower wax over here, and at the same time we added the emulsifier sterile alcohol or sorbitan monopolymetate over here. Then we heated it in a water bath at 80 degrees centigrade. Take it on that side at 80 degrees centigrade, and then we mixed it to achieve a homogeneous solution. So we got a homogeneous solution. We homogenized it at 300 rpm on a magnetic stirrer, and then we kept it for crystallization for at 25 degrees centigrade to form oleogels. So this is the final oleogel what we got. Okay. So this is the composition of the formulations what we developed. This is the sunflower wax, sunflower oil, then emulsifiers we have added. So these SA formulations, they consisted of sterile alcohol, whereas SP formulations, they consisted of sorbitan monostearate or span 60. Okay. Now these are the pictures of the formulations. So over there, if you see, when the left hand side, the samples on the left hand sides, they are the formulations when the samples were hot in nature, and it was having a clear solution, okay, clear homogeneous solution. As we start to cool it down, it's initially turns cloudy, and then slowly it forms gels, and the what do you call these pictographs of the samples, they are given on the right hand side of the image. Okay, so these are the control signal sample. Then SA1, SA3, SA5, SA10. These samples, they consisted of sterile alcohol in increasing concentration. Similarly, we also had this SP1, SP3, SP5 and SP10. So if you look into the samples, they appear as yellowish white in color. Okay, so these are the oleogels which we got. Now, one of the important parameter while we develop any kind of formulation is the color parameter. So in our lab we have developed a colorimeter, okay, indigenously. If you try to go for the what you call procurement of such a kind of colorimeter, it costs you approximately around somewhere around 2 lakhs to and it may go as high as 12 lakhs, 15 lakhs. However, in our lab we were able to develop it at only 15,000 rupees. Okay, so the principle is very simple, which I will not go into the details over here. Okay, so we analyze the colorimetric and the oil binding capacity of the gels. Now, why we want to perform the oil binding capacity? This is because the higher the oil binding capacity, the longer will be the stability of the oleogels. Okay, why? Because if the oil binding capacity is lower, then what will happen? The oil would start syneresis from the gel systems, and it will try to come out, and it will come out on the top of the gel systems, and you will see a layer of oil settling depositing over the gel based system. So that is a sign of instability. Similar thing you can also see in the ointments, in many of the ointments, if they are not formulated in a proper way. So how this oil binding capacity was determined? It was determined by the centrifugation method, and you can get the details of the method in the paper which I have already shown you in the title slide. So that paper is freely available. It is an open access paper, so you can go over there and you can look into the thing. So in all of these oleogels, whatever we have used, we have found that the oil binding capacity was more than 99%. That means the addition of the emulsifiers within the control system has not altered the oil binding capacity. Okay. However, when we try to analyze the color of the samples, we found that there were certain changes in the color parameters. In the colorimetry, you will find there are three parameters which we have determined. The first one is L star, A star and B star. Since many of you are from the pharmaceutical background, you may not have an understanding about the colorimetry, but you must be knowing that our digital screens and all these things and the color images we represent it in the RGB format. Okay, there is similar to the RGB format, there is another format which is called L star, A star, B star format. Over here, this L, it stands for lightness. A and B, they are chromatic values. A star values, it gives you information about the green and red, whereas B star values, it gives you information blue and yellow. So if you see in the RGB, we are only discussing about the three colors, whereas in LAB value we have a component which is independent of the chromatic values, that means the color values, and also we are discussing about four chromatic parameters, that is green, red, blue and yellow. Okay. So why L star is important? L star is important because it will give you information how your sample surface it is reflecting or refracting the lights. Why this becomes important? This becomes important because I told you that fat crystals are being formed which are at a microscopic level, and any deviation in the microscopic level would result in the changes in the L star value, that means the reflection pattern of the light. Okay. So if you see this hash signs, they show that suppose in control and SA3 we are showing this hash line, that means there is a significant difference between control L star values of the control and the SA3, and the significance level we have taken it as 0.05. Okay. So if you see clearly over here in SA3 as compared to the control, there was a decrease and then again there was an increase in the L star value. Okay. So this decrease, SA3 decrease, it was significantly different or significantly lower as compared to the control. In SP or the span 60 based formulations, again if you see at SP5 we were having the lowest L star value. Okay. Then when we looked into these A star values, when it is negative, that means we are having green component. When it is positive, we are having this red component. Okay. So over here, if you see the A star values, they were negative in nature. That means the green component, it was prevalent in all the samples. Okay. Similarly, when we looked into the B star values, the negative values, it shows blue component, whereas positive values, it shows yellow component, and herein we were able to see the yellowish component. Okay. Now the thing over here is that you would say, sir, in the images we could not see any green component. Why we didn't see? If you compare the A star values, they are all limited within a range of 0 to -10. Okay. Whereas the blue components, if you see, they are much higher than the A star components. So we can say that the yellow component, it is giving a very it is having a large proportion into the sample as compared to the A star values. Also, if you go back to this sample, it was having a yellowish tinge, okay, but it was again yellow, whitish in nature. Okay, if you look into the L star values, all of them, they are having an L star value of greater than 90%. That is, most of the light are being reflected back. Okay, so due to this reason, the samples, they were appearing as white, and due to the higher components of the B star values, the samples were having a yellowish tinge. Okay, so then we went for the microscopic analysis. So initially we did it for the stereo zoom microscope, then we have a bright field microscope. We analyze the micrographs using the bright field microscope. However, if you see the bright field micrographs, many a times they do not give you very good information. So we converted our upright bright field microscope, compound microscope, into a polarizing microscope, and this is what we did it. We used a polarizer, and to this, what do you call it, eyepiece lens, the objective lens, we added one this polarizer over here, and we converted the upright bright field compound microscope into a polarizing microscope. And this is one of the examples where we have taken the image of an oleogel through the converted polarizing microscope. Okay, and stereo zoom microscope, I hope every one of you know that it gives you information about the surface characteristics of the samples. Okay, now microscopic analysis. So stereo zoom microscopy, it gives you an information about the surface topology. Okay, now on the surface you will see some bright spots over here, and there will be some darker spots. So these bright spots, they are agglomerated structures which are being formed by the crystallized fats. Okay, now if you see, in comparison to the control in SA1, SA3 and SA5, as the emulsifier content was increased till SA5, this agglomeration, it was increased, and also the crystal size was increasing. However, when we increase the concentration of the emulsifier at SA10, there was a marked reduction in this crystal formation. Okay, similarly, if you also look into this SA3, if you see, there is the agglomerations, you can see quite clearly over here. Okay, and this was again, it was improved in SA5, however in SA10 it totally diminished. So if you look into our example, what we have done is that we have added the emulsifiers at a concentration of 0.005% up to 0.5%. Okay, so in this range the emulsifier content was varied, and since it was varied in such a minute concentration, this means that even at a very low concentrations, the emulsifiers have the capability to tailor the fat crystal network which is being formed for the analysis of for the development of the oleogels. Okay, on the contrary, if you look into the SP category of samples, where did we find at the initial stages? If you see, there are less crystalline structures. However, when we got into SP5 and SP10, they were having microstructures which were similar to, say, the control. Okay, so we can see when we have used the emulsifiers of different the different HV values, they are tailoring the fat crystals the structures of the fat crystals in a differential way, in a concentration in a concentration dependent manner. Okay. Then again we went for the bright field microscopy. As I told you, we have the bright field microscopy. If you see, some fiber like structures are being formed over here. Okay. And as we are increasing the thing, if you see at SA10, long fibers were formed, and in between if you see the voids, those voids were quite high. So when we analyze this assay based system, we were able to see the microstructures to a certain extent. That was very appreciable. However, when we were analyzing these SP based categories, if you especially see the SP5 and SP10, we were not able to see any distinct microarchitecture within these two samples. Okay, and this is the limitation of bright field microscopy. Okay, if you want bright field microscopy, it helps us in analyzing a lot of things, no doubt, but in many cases where there is a very minute changes in the refraction between the continuum phase and the dispersed phase, it fails to give us some distinct microstructures. Okay, so due to this reason, we again took this what you call pictures or the micrographs of the oleogels under the polarized microscopy. And over here, if you see, it is the in SP5 and SP10 there are distinct fat microstructures are there, but they were not visible in the bright field microscopy. Okay. However, here also if you see these fat crystals, they are appearing as the fiber like structures, and these fiber like structures, they are forming network, and within that network you will be finding that these black dark voids are there where it is expected that oils are entrapped. Okay. Then coming to the molecular analysis in the FTIS spectroscopy. So in the FTIS spectroscopy, if you see, we got CH bending and this CH stretching, CH bending of the alkane and CH stretching of the alkane. The presence of these two peaks, they are associated with the orthorhombic subcell packing, and they are associated with the beta prime polymorph of the fat crystals. Okay. From here we were speculating that this beta prime polymorph, which is important in food products, that is present. Okay. Why it is important? This is important because beta prime polymorph, it is one of the most stable fat crystals, and if these polymorphs are present, that indicate that there is a very good subcell packing, and the oleogel based system what we have developed, it may be stable for a longer period of time. However, we needed the confirmation of that one. So these are just the FTIS spectroscopic of all these things, so I will not go into the details of that. So for the confirmation, we went for the XRD analysis. In the XRD analysis, in all the samples, if you see, we found peaks at D equal to 4.12 angstrom and D equal to 3.72 angstrom. So these the presence of these two peaks confirmed the presence of the beta prime polymorphs, the triacylglycerols, into the oleogel system. So from there we calculated the crystallite size, percent crystallinity, lattice strain, and dislocation density. Now over here, if you see the crystallite size, it is varying as we are adding the emulsifiers in different concentrations. Similarly, the percent crystallinity is also is varying, lattice strain is also varying, and finally the dislocation density, it also varies. Okay. Now then we perform the crystallization kinetics. It is basically you heat up the sample at a temperature of 60 degrees centigrade, and with time then you incubate the sample at a say 5 degrees centigrade water bath or whatever, and you continuously measure the temperature of this one, and the profile what you will be getting, it is regarded as the crystallization kinetics. Okay, now all these fat based systems, they would show you three stages. Initial stage, where the fall is nearly linear, then there will be an exponential decaying stage, which is called the intermediate stage, and lastly the saturation stage, where the fat crystals, they grow in they undergo saturation. Okay, so that is the saturation phase. So in all of these things, we saw that the addition of emulsifiers, it has altered the crystallization kinetics. Okay, now from there we calculated the rate of crystallization. If you see, with respect to the control, all of them, when we added the emulsifiers, whether it is a low HLB value emulsifier or a high HLB value emulsifier, all of them, they have increased the rate of crystallization. Okay, again if you look over here, it was 150, then at SA3 it increased, then it started decreasing. In the span 60 based these oleogels, so we had the highest rate of crystallization. After that it reduced to the lowest, and it remained in this range for the rest of the samples. Okay, so you can see how the emulsifiers, even when we have added it in a very low concentration, it is affecting the properties of the samples. Okay, then we performed the DSC analysis, which is the thermal analysis. Okay, and the first one is the melting curve, second one is the crystallization curve. So we did the analysis in the range of 0 to 100 and back. So we got that we got a melting peaks, we got crystallization peaks at different temperature depending upon the nature, and then what we had this degree of supercooling, which is basically melting temperature minus the cooling temperature. So there will always be a what you call there's a difference between the melting temperature and the crystallization temperature. So that difference, it is regarded as the degree of supercooling, and degree of supercooling, it affects the crystallization process. So over here if you see, it was 1.30 degree centigrade in the control, and in the samples if you see, it has varied in a composition dependent manner. Then we performed the mechanical study. We performed the stress relaxation study to analyze the mechanical properties of the oleogels. We did not find any specific changes in the mechanical properties. Okay, this was important because what we want to do, we want to alter the differential properties of the oleogels without compromising with the mechanical stability or the oil binding capacity of the systems. Okay, so then we performed the nutrient release study. Over here we used curcumin as the model nutrient, and we got this release things over here. So this one for the SA based samples, this was for the SP based samples, and then we modeled the initial part of the release through the paper saline models. So C and D, these are the model parameters. So again if you see this diffusion parameter, it is changing in a differential way, and then the looking into the kinetics, what kind of kinetics it was following, except this SA5, rest of the samples it followed a Fickian diffusion kinetics. Okay, so in conclusion we found that the oleogels what we have developed, it was having more than 99% of OBC, that means the oil binding capacity. Then all the samples, they were having fibrous network. However, there was a variation in the length, thickness and branching depending upon the composition of the oleogel. Okay, Then SA10 and SP10 had bright fat crystals with dense packing. That means when we increase solid emulsifiers into the system, there is an increase in the packing density of the fats. Then SA10 it showed the largest crystallite size, whereas SP10 it displays the highest crystallinity. Okay, all the formulations they were having similar FTIR spectra, but they showed that the beta prime polymorph was present over there. A lower crystallization rate in SA10 and SP10 it indicates the formation of a stable and accurate packing of the fat molecules. Then we got higher delta HM values for the DSC curves in SA10 and SP10. This suggests their better thermal stability over the other formulations. And lastly, we found that there was a sustained release of the curcumin. Okay, so these gel-based systems, oleogel-based system, it can be used as an what you call controlled delivery systems for the nutraceuticals. Okay. So these are some of our notable national collaborators. Then we collaborate with some of our international collaborators also. So this is our YouTube channel where we put up regularly what activities are going on in our lab. So if you are interested, you can visit the channel. And thank you all. Before I hand over the things to Professor Swai, I would like to conclude that teachers thrive on the success of their students. So this work, what I did, it was done by Deepthi Bharti. She is a PhD scholar and she will be submitting her thesis in a month or two. So I take this platform to wish him best of luck in her future endeavors. So with this, I thank you all for your patient hearing. If you have any questions, I'll be happy to answer those.